I just graphed it, and you can see that you have an asymptote at y equals -3, and immediately you can rule out options A, B, and E because you can clearly see that the domain is from -infinity to infinity, and for range you can see that it would go from -3 to infinity inclusive. So these are the only. Question 2, A and B are obviously wrong. So I just check C, D, and E. So I'd first start off with C, and this would be the graph. And you can see that the maximal domain for root 5 minus x is -infinity to 5. So C is the option here. Question 3, f dash x is -8x divided by x plus 2 to the power of 3. And f dash 5 equals -8 on 7 cubed, which is option C. Question 4. I just graphed -2 ln x just to see what was happening here. And I noticed that as the x values got larger, the corresponding y values also got smaller. So g of A would be the right endpoint, and g of B would be the left endpoint. So option C would be the answer here. Question 5. I just integrated f dash x, and you get -1/3 cos 3x plus k. And then to solve for k, you would do f of pi on 4 equals 0, and then you get k equals -√2 on 6, and then f of x equals option A. Question 6 is just PR x equals 9 plus PR x equals 10, and that's 10 choose 9 times 1 to the power of 5, 1 on 5 to the power of 9 times 4 divided by 5 to the power of 0, I think. Yeah. And you add that to 10 choose 10 times 1 divided by 5 times to the power of 10 multiplied by 1/5 to the power of 0. And then you can simplify that to 10 choose 9 times 1 divided by 5 to the power of 9 times 1 plus 10 choose 10 is 1 times 1 to the power of 5 to the power of 10, and then times 4 divided by 5. And that's option E. This question, I noticed that you can use z equals x minus u to the power of 0, but first you have to get into that form. And to get that, I did inverse norm of 0.1101, and that's -1.266226, and then 5281, and then inverse norm 0.9301, 1.45791, and then you can solve the simultaneous equations that you get there. You just have to plug it into this formula, and you would get option E. Question 8, you kind of just have to list every single possibility, and there's like a fair bit, so it takes a little bit of time. So I got 4 3 times, 446, 464, then 644, and then I got 664, 646, then 466, and 66, -1, 6, and 666, and all of these possibilities, they all add up to numbers over 10. So you'd have to notice here that these three have the same probability of occurring, and same with these three and these three as well. So when you're calculating the final answer, that's just important to note. So the probability of some x is greater than 10 is, first you would start off with here, 0.5 to the power of 3 plus 3 times 0.5 squared times 0.3. Add that to 3 times 0.3 squared times 0.5 plus 3 times 0.3 squared times 0.2 plus 0.3 squared to the power of 3, and that will give you option E. Question 9. G of x plus 2 is x squared minus 5x, which means g of x equals x minus 2 squared minus 5x minus 2, which simplifies to x squared minus 9x plus 14, which is option E. Question 10. I graphed this out to properly see what was going on. I just graphed 3 sine pi x on 10 minus 1, and you kind of get a graph like this. Each cycle is 20, so I'm just going to note that down. And you can see that in each cycle you would have 2 x-intercepts. So if you want to find 5 x-intercepts, you would have to go a little bit over 40, because if you go over 60, you would have like a bit more x-intercepts. So you can automatically rule out these 3 options, and you would have to select option D, because that's in that interval you would get your 5th x-intercept, and you wouldn't have to go further. Question 11, I just graphed these on my CAS, and I got option A. Question 12, I simplified each of these matrices, and it's just a bit of work here you have to do, and you would just simplify it and get the transformations. And likewise, you would do it for each of the other options. And option B was the correct answer, and I'll show you guys why. So you would get the matrix as half x minus 1, 8 minus y. So x dash equals half x minus 1, and y dash equals 8 minus y. And then you cross multiply, get this if you want to solve for x, and likewise you do it for y as well. And then you just put that back into f of x. So just do this here, and 8 minus y equals 2x plus 1 squared plus 3, and that simplifies to negative y 2x plus 2 squared minus 5, and this matches with g of x over here. So that's why option B is correct. Question 13, you can automatically rule out A because that gives you a quadratic, and this is clearly a cubic. You can rule out option C as well, because it's a negative coefficient in front. And I just subbed in 4, 5 into each option, and I got option D was correct. So that's what I did. Question 14, I used my CAS to solve this. I did y equals log b 3a minus 2x whole squared. I just solved that, and it gives you x equals, it gives you x equals 3ab y minus 1 times b to the power of negative y divided by 2, and you can further transform that into x equals negative half, positive half, 3a minus b to the power of negative y. This is the same thing. And that would be option C. Question 15 is just product rule over here. So f dash x equals g of x squared times d dx of cos 2x plus cos 2x times d dx of g of x squared. That's negative 2 sine 2x g of x squared plus cos 2x 2gx g dash x. You can get this by using chain rule. I'll just quickly show that. And you get 2gx times g dash x, which is what I plugged up in here. And if you factorize this, you would get option C, because you can take out the 2 and the gx. Question 16. I just rewrote this first real quick. And then I broke up the function. That gives you, you take the 3 out as well. I'll just write that over here. And that gives you 3 times 12 minus 6. Yeah, and that's 30, which is C. Question 17. It's a continuity question. There's 3 conditions for continuity. First one, f of a has to exist at a certain point. Limit x goes to a, f of x has to exist. And the third dot point is what I'm going to use here. Limit x goes to b minus f of x has to equal limit x goes to b plus f of x. And that's log e b, I can write that here, log e bb, just plug that stuff over here, equals to b on 2, which you get from the first function. And then you can do log e b equals half. Then e to the power of half equals b. So that's A. Question 18. The function is odd because it tells you that, and the terminals can be reflected in the x-axis. So you would essentially have 0, negative 4 f of x dx equal negative 4, 0 f of x dx, which is negative 5, because this is given to us as 5. So that's A. Question 19. The area under this curve would have to equal 1. So you would have to set up an equation that equals to 1. And that's just this. You just plug this equation into your CAS. The reason I wrote this over here as the upper boundary is that you just want to be finding when m equals 0. Sorry, what the t value is when this function equals 0, and you would get t equals negative 3 on 50m plus 10, and you just plug that in over here. And once you solve this equation over here, you would get option D. Question 20 is just a standard differentiation question. So I'll let the area equal A, and the area is 10x minus kx cubed, because 10, and then, oops. Yep. So dA on dx equals 10 minus 3kx squared. And to find the x value that gives you the maximum area, you would equate a dash x to 0, and you get x equals root 10 on 3k. And to get the maximum area, you plug it back into A, and you would get 10 times root 10 on 3k minus k times 10 on 3k to the power of 3. That has to equal 20 as well, because maximum area is 20. And you solve for k, and k is 10 on 27 if you plug it into your CAS. So that's 20D. That's multiple choice. Question 1. To find the turning points, you just equate f dash x to 0, and you get x equals negative 3, x equals 0, and x equals 3. Now to find the turning points, it's just negative 3, f of negative 3, 0, comma, f of 0, oops, and, all, so should be all, 3, comma, f of 3, and your 3 turning points are negative 3, comma, 0, 0, comma, 27 on 10, or 3, comma, 0. Question B, just use the point gradient form for this question, and you can get y minus 27 on 10. The gradient here is 0, x minus 0, because you're just using this point up here, and the gradient at this point 0 as well. So that's how I got this. And just rearrange this, and the tangent is y plus 27 on 10. For this question, to find the point of intersection, you would just equate f of x to 27 on 10. And when you solve that, you get x equals plus or minus 3 root 2, comma, x equals 0. Therefore, the points of intersection are 3 root 2, 27 on 10, because you just, the y value in each of these coordinates is 27 on 10, because you can just get it from here. 0, comma, 27 on 10, and negative 3 root 2, 27 on 10. Question C. The first thing to notice here is as soon as you start subtracting any value from f of x, you would automatically have 4 x-intercepts. And the other thing to notice here is this pattern stops once the maximum touches the x-axis, and the maximum here is here, 27 on 10. Once this value touches the x-axis, you wouldn't have 4 x-intercepts anymore. You can graph this on your CAS and it'll show you that as well. So the answer here has to be any value between 0 and 27 on 10. Any value here is valid. In II for k, you would just do g of negative 2 equals 0, and that's f of negative 2 minus k equals 0, because g of x equals this. And when you solve that, you can use your CAS for it as well. You get x equals 5 on 6. For the next question, I just use my CAS to find the value of the tangent, the equation of the tangent, and you get y equals 4 divided by 3x plus 7 minus 2k divided by 2. And now they want you to find the value of k. So to do that, you would just equate 7 minus 2k on 2 to 3, because you want to match this format over here with this. And if you cross multiply and then solve it, you get x equals half. Part D, you want to be finding, first find the x-intercepts of h of x. And those x-intercepts are, there's 4 of them as well. 9 minus root 30b, minus root 30b, and this. And we have to remember that b is greater than 3. So the only 2 valid x-intercepts are x3 and x4. So now we have to solve for b, because that's what the question's asking us to do. So for b, you would make x4 your upper boundary and x3 your lower boundary, and just integrate that function and equate it to 15, because it tells you that the bounded area is 15. And you get the b value to be approximately 3.0254 to 4 decimal places. So that's question 1. Question 2, find the area bounded. Okay, so the area equals upper boundary 30, because that's the max value you can take, and 0 lowest value, and then r1x minus r2x. I forgot to say this line here is r1x, and this line here is r2x. You can just get that by plotting these 2 functions in your CAS. And this area here is 30 ln 6,000 units squared, which is approximately 260.985 units squared. I guess you could keep it in exact form. They don't ask you to actually evaluate it. Okay. Part B. So now you want to find the difference in area. So the difference in area is area bounded by, I won't write it, area bounded by R1 and L minus the area bounded by R2 and L. So that's going to be up boundary 30, lower boundary 0, R1x minus Lx dx minus this Lx minus R2x. You have to be careful with how you arrange the functions inside, because you have to remember that L of x is greater than R2x. That's why it's like somewhat similar to that shape over here. It just helped me visualize it a bit better. So once you solve this integral with your CAS, you get 25.96 units squared to 2 decimal places. That's pretty much all you have to do for that question. Part C, the distance equals you can use distance formula here because it's relevant to the next part of the question as well. So that's going to be 2ln 300 minus ln 15 squared. And that's equal to around, I'll just write the exact value, ln 6,000. So for the next part of the question, this is where you would actually have to use the distance formula. So let d equal this, x minus 20 squared plus r1x minus ln 15 squared. Let's start brackets. All right, so for stationary points, you would have to equate d dash x equals 0, and that gives you x equal negative 10, x equal negative 9.9, and x equals 19.71. So these two are maximums, and this one is your minimum that you want to find. So to find the coordinates that Wendy needs to travel to, it's just 19.71, comma, R1 of this value, which is 19.71, comma, 11.40 to 2 decimal places. All right, so for part I, tan theta equals 11.4 minus R2 theta, and 19.71 minus 20, and then theta equals tan inverse of this big thing over here. So the theta value you get is negative 1.53744 radians, but they want you to find the final answer in degrees. So just multiply this by 180 on pi, and that's negative 88.0891 degrees. And for the amount she has to rotate before she walks in a straight line, you'd have to subtract this from 90 degrees, and that will give you 1.91 degrees, because she's already facing north and she has to angle herself westwards. That's why you have to subtract it. Question D, the gradients 1 and 15. It's a pretty easy question here. You can just use the transformation here. So it would just be 5 plus 3 comma 9 plus 1 on 5. That's equal to 8 plus 46 on 5. Just two easy questions there. Part E, I simplify this matrix a bit, and that's going to be mx plus 10m minus 10 and y at the bottom. That gives you x dash equals mx plus 10m minus 10 and y dash equals y. So y equals y dash, and x equals x dash minus 10m plus 10 divided by m. So for R3x, just plug in the x and the new x and y values. That's going to be log e x dash minus 10m. I can just get rid of the dash. Minus 10m plus 10 divided by m. Just plug in that value here into the function, and then just do this. And if you simplify this, you get log e x dash plus 10 divided by 2m, which equals, oh yeah, that's fine. Yeah, okay, now to find m, you just do R1 minus R3 equals 10, because it tells you the vertical distance between these two functions is 10 meters. And when you solve that, you can get m equals 1 on 6,000 e to the power of 10, which is approximately 3.67. Question 3. So first of all, PR W is greater than 1.65. You can just solve this using CAS, norm CDF, and just 1.65 infinity, 1.5, 0.14. That's equal to 0.141988. So you multiply that by 20, because you have 20 chickens. That's approximately 3 to the nearest whole number. PR W is less than 1.2 equals, you can just use your CAS again, it's a norm CDF function, and that's equal to 0.016062. Part C, this is binomial, so x by 30. Oh, that's a bit messy. 0.016062. Yep. And PR x is greater than or equal to 1 equals binom CDF 30, 0.016062, 1, 30. Just plug that into CAS. 3848. That's the answer. Part D, you want to be finding probability of. First, let's just evaluate this. 1.70. That's not. You can just put that in the CAS norm. CDF 1.5, 1.45, 1.7, 1.5, 0.14. That's 0.562944. So now getting on to what that question is actually asking us. PR x is greater than 1.55, given that x is in between these two. So that's going to be PR 1.7, x is in between those two, and PR of 4.45x. X is between those two again. You already have this value over here. I found it up there. Just plug that in, and you can evaluate this using your CAS. And that's 0.5044. Oopsies. To 4 decimal places. Part E, it's binomial distribution again. And PRX is less than or equal to 14 is binom CDF 45, 0.3591, 0, 14. That's 0.3071. This question, E of X equals N times P, and N is 45 and P is 0.3591, which is approximately 16.16 to 2 decimal places. Standard deviation is square root of the variance, and we know that the variance is NP times 1 minus P, which is 16.9595 times 1 minus 0.3591. Yeah, that's 10.3566. And SD of X equals the square root of the variance, which is 3.22 to 2 decimal places. So I couldn't do F and G, as and you get P-1x equals this big thing, x cubed minus 3x squared divided by 10 times 3e to the 5th x squared divided by 10 minus 3e to the power 215x divided by 5. That's the derivative. So to find a, to show that a equals 2, first of all, you have to show that p dash x equals 0, and then you get x equals 0 and x equals 2. Therefore, 0 comma a, which is our domain up here, equals 0 comma 2, and you can equate a to 2. Part C, something we have to remember here is that a function and its inverse always intersect at y equals x. So instead of trying to find the inverse function, because it's going to be like really hard, you just equate this to x. And once you solve that, you get x equals 1.16346 or x equals 3.66858. And that means your point of intersection is going to be 1.16346, 1.16346, because it's on the line y equals x. So the reason I didn't include this value here is because a is in between 0 and 2. But I wrote this down because it's going to be important for a future part of the question. Okay, for part D, it would be helpful to just graph it out. It's a bit tricky to graph, but yeah, I guess you have to do it. So first, start off with y equals x. Oops. And the graph of P1 is something like this. Something like that. And then you would kind of have to like estimate how you're going to draw this. And the inverse would be something like this. Because it's it's like this. So the area you want to find is essentially this part. Okay, so to find that area, you would just do 2 times the integral of 1.6346 P1x minus x. You can't really see from my drawing, but the reason I put the 2 over here is because they're symmetrical across y equals x, so the area is the same. So you would get 1.81 units squared to 2 decimal places. Part E, range of P2, that's going to be 1, infinity. Part F, one endpoint of this is going to be 2, P2, which is, because it tells us right here, which is 2, 1. That's an endpoint for P2. So naturally, the endpoint for the inverse function of that is going to be 1, 2, because you just swap it. And then you would get the line y equals x, negative x plus 3. You just find the gradient of these 2 points, which is this, negative 1. And then to get the c value, you just plug it back in. Nothing too hard there. Okay. Next question, GI. This is where the value I found up here, this is where it comes in handy. First of all, I'll just graph it out real quick. They want us to find the area between x minus 3 P1x and this is a really bad drawing, but it's kind of what it's supposed to look like. So this is going to be the 2 intersections between the 2 graphs are these 2 values over here. So this is 3.66858, and this one is, we found this earlier, 1.1 something. Oops. 1.16346. So the area over here is going to be 2 times 3.66858, 2 on the lower boundary, x minus P2x dx, yep, plus 2 times 2, 1.5, x minus x plus 3. Oops, I forgot to draw y equals x. So that would be the total area you need to find. I forgot to say that you get this because that's the intersection of x and negative x plus 3. So that's the integral you would need to solve. And once you solve that, you get the answer to part II, which is a equals 4.60 units squared. Part H, they give you one endpoint already, and that's K. So one endpoint of Q is going to be K, comma, Q of K, and naturally the endpoint of Q inverse is going to be Q of K, comma K. So to find K, you would just equate Q to K to Q of K, and you get K equals 1. All right. Part I, you have to remember that inverse functions only exist if the original function is 1-to-1. So you just have to cut the graph off at the turning points. So to find the turning points, you would have to find q inverse q dash k, and then equate it to 0 for turning points, and that gives you x equals k minus 2 on 3, or x equals k. So you have to remember that k is going to be greater than k minus 2 on 3, and if you change that around, you get k is greater than negative 1. So the smallest value has to be negative 1 of k. Part J. When Q and Q inverse share the same tangent, there's only going to be one intersection, and that intersection has to be on the line of y equals x as well. So you can get Q dash of x equals 1, because the gradient of the y equals x line is going to be 1, and you can get Q of x equals x. You just solve these two with the CAS, and you get x equals 1.40392 and k equals 0.215933. So I got stuck over here because I didn't know why they included 1 to infinity in the values of k. I thought it was just going to be this one.
It's cause like if you draw the graph, it's like how do I? Can you see this? Can you see that? This one. So as Amaan said, when you equate the simultaneous equations of, so that's not the right sign. So qx equals x and q dash x equals 1. So this is when, so you have your graph of qx and q inverse x. So if they have one point of intersection, when you solve for this, you get the k value for this situation. So you get like, I think he said, k is 0.2159. But the other possibility of getting one intersection is if you have your q function and your q inverse function like this, because the range, as we figured, the domain is restricted from k to infinity. So you don't have to worry about a second point of intersection like here. You don't have to worry about this because the endpoints prevent that from happening. So once you go past like the graph looking like this, if you move this graph to the right enough so that it looks like this, then you also only get one point of intersection. So that's where you get 1 from, because 1 is, I think the answer here was k is 1. So if they have the same point of intersection, so like this situation, then k is 1. So if as k increases, this graph here moves to the right. So you get like, it moves to the right and the other one moves up. So it'll go like this. And then that's why you only have one point of intersection. So yeah, so that's why it's, so one answer is this. So k is an element of 0.2159, union 1 to infinity, because as the more you increase k from 1, the like more separate these two get. So they keep going like, the gap here gets wider and wider. Yeah, I hope that made sense. I guess I'll explain k as well. So k is like related to this situation. So as you can see, when k increases, the graphs keep getting wider and wider. they keep going like this. And basically it's asking, as K increases, what angle will this become? And you can clearly see it's going to become 90 degrees because the graph here has an increasing gradient, so it's going like this. And like eventually it'll get to here, not like when x is infinity. And the graph of this one has a decreasing gradient, so it's getting flatter and flatter. So you have a vertical, eventually you have a vertical one, and this graph will be horizontal. So that's why eventually theta will go to 90 degrees. I think the answers had like a really not algebraic, but they like try to explain it. But yeah, that's pretty much it. You can just see it graphically. That's, I think, the only way to solve the question. I guess I'll go back to the probability part. Was it this question? Was it F? Sorry. I think it was F. So we're starting off with normal distribution. You can see that from here, the n here represents normal distribution. And as Amaan said, it's just a Cas function. So you just do probability that the weight is greater than 1.65. But this is the amount of chickens. So after you get the probability, you have to times it by 20 chickens, because that will be the amount of chickens. And you get like 2.84 something, but you can't have a decimal amount of a chicken, so you have to round up. So you get 3 chickens. Again, if this is under 1.2, it's just, you can just do probability that W is less than 1.2. But the thing with this question is that it's asking for a percentage, not just a probability value. So you do have to multiply this value by 100 and round to the 2 decimal places, and you get, sorry, this is, that's wrong. But yeah, you just round to 2 decimal places and you get 1.61%. This is 0.061. This one's the answer. So C, now there's 30 chickens, and find the probability that he'll be able to claim a refund for at least one. So now they've converted the normal distribution to binomial distribution. So now we have probability that there's a refund for at least one. And you just put n is 30, and the probability, as you figured out in the previous question, is 0.0161 approximately, but like keep the values in your Cas, and you should get 0.3848. So next question is that the supplier guarantees that the next 50 chickens all weigh between this. So this is a hidden given question. This implies that this is a given statement. So that's important to note. And then find the probability that a random chicken will weigh more than 1.55 grams. So this is asking for a probability that W is greater than 1.55, given that it's between 1.45 and 1.7. So again, the numerator, when we expand this, is the intersection of these two. So it would be 1.55 weight is between that and 1.7 divided by the given function. And you can just put this into your Cas, and you should get 0.5044. So now there's a different variable, so we can ignore the stuff that we've done before, and this x is a discrete random variable. So there's 45 food critics, and it's known that the probability to get 5 stars is this much. So find the probability that no more than 14 critics rate the restaurant with 5 stars. So this is our binomial distribution. So we're just looking for a probability that there's between 0 to 14 food critics, and it's 0.3071. So just with the wording, it says no more than 14, so that means 14 or less. So EX, as Amaan said, is just NP, which is 45 times 0.3071, and you get 16.16. Yep, which is kind of unrealistic again because we're talking about humans, so you can't have 0.16 of a person. So now it's asking for standard deviation. So we know in binomial, standard deviation is NP minus P. And that's 45 times 0.3071, 1 minus 0.3071. And to 2 decimal places, that's 3.22. So now we're at the sampling part. I think the sampling part was pretty okay. Maybe it was just worded a bit harshly, but so there's 26 roast chickens, so that's your sample amount, and the probability is 0.92. So at first it's asking for the probability that P is less than 0.8, so we know we can't find probability if our variable is P, so we can convert it to something. The most convenient here would be to convert it to X. So if we're converting P to X, we have to multiply P by N. So that would be 0.8 times 26, which is 20.8. So in this case, we're asking probability that P hat is less than 0.8, which we just found is equal to the probability that X is less than 20.8. But again, he can't have 0.8 of a chicken. So since it's less than 20.8, you actually round down to 20. So X is less than or equal to 20, because if you think about like a number line, you have 20.8, you have 20. If it's less than this, and you're only choosing whole numbers, it's going to be from 20 to less than that. Oh, no, 0.8, my bad. So we're converting the little p value to little x. Is that okay, sir? So in your case, to find this value, you would put the sample size is 26 and the probability is 0.92. That's stuff we got from the question. And you get 0.0149. So standard deviation of P is pretty easy. You just apply the formula that we know. So P, 1 minus P on 9. Again, N is 26 and P is 0.92, and to 4 decimal places, you should get 0.0532. So next question is find probability that the sample proportion in sample of 26 is within one standard deviation of 0.9. So probability of 26, so similar to the previous question, but it's one standard deviation of 0.9. So we found our standard deviation here. So we're doing 0.9 minus 1 standard deviation, sample proportion, and then 0.9 plus a standard deviation. Sorry, my standard deviations kind of look like a 6, but it's not a 6. And you get 0.8488-ish. I'll just leave it at 0.84 P, and this one is like 0.9532 something. And again, we face the same problem as before, that we can't find probability if it's in terms of P, so we need to convert it to something else. So in this case, it says don't use normal approximation. So we are going to convert it to a variable, but the way we're going to use our CAS is not going to be normal approximation. So first we have to convert it to another variable. So I'll name it x again. So same thing as before. You multiply this by n, because when we convert p to x, so x is n times p. So multiply both values by 26. And you get 22.02 x, x and 24.78. Since it says normal, as I said before, we can't use normal approximation, so we have to use binomial approximation. And because it's binomial, that means we're dealing with discrete values. So we have decimals here, but we can't use decimals. So we have to think of the number line again to figure out whether we round down or round up. So we have 22.02, and the closest would be 22 and 23. The other one is 24.78, and the surrounding is 25 and 24. So we're going from here to here. So you can see the numbers we're going to include is from 23 to 24. So finding between 23 to 24 inclusive. Always be careful of whether the inequalities are inclusive or not, especially in binomial, because that will determine what your upper and lower limits are when you put it into the CAS. But yeah, now you can put this into your CAS straight away. So n is 26, and as from the previous question again, p is 0.92, and you should get 0.4768. So now we're at the another working day. So there's M roast chicken, so that's the sample size. Now it's been removed, we don't know what it is. And there's a 95% confidence interval, we can assume, that Jimmy will approve of 73 to 0.9% of chickens of that day. So these are proportion values. So you can tell this is our confidence interval for the proportion of chickens that will be approved of by Jimmy. So a 95% confidence interval is this one. Interval is from 0.73 to 0.97. So we know to find a confidence interval, the formula is p hat minus 1.96. P1 minus p on n, but in this case n is m, so I'll just write m instead of n. And p hat plus 1.96 square root p1 minus p on m. So we're missing two things. We don't know what we don't know what the probability is, and we don't know what m is. The probability is really easy to find, because if you look at this confidence interval and you realize that so this values, so in this, the lower limit, so we're adding the same thing as we would to the higher limit. So just by realizing that, you can tell that p is going to be the middle value of these two. So p is going to be 0.73 plus 0.97 divided by 2, which is 0.85. And then you can take, because now we have p, you can take either the lower limit or the upper limit and just equate it to one of these values. So if you take the upper limit, for example, you get 0.97 is p hat, which we know now is 0.85 plus 1.96 square root 0.85, 0.15 on m, and just solve for m. I think you get a decimal value again, but like 33 point something. But again, you have to round up because it's m is an element of the integers. So m is 34. So now there's m minus 34 amounts of chicken. So m before was 34, so there's 29 chickens. And so now they're changing the confidence level. So it's now no longer is it 95%. And so now we want the same, so we're given the same confidence interval from 73 to 97, but they've changed how confident he is. So we can use the same thing except as we did before, except this time we're trying to find a different value, I guess. So we have 0.73 to 0.97. And again, that's from p minus, but this time we don't know what the confidence interval is. So the z value in front of this will remain unknown. So again, since it's the same confidence interval, our p-value also remains the same because it'll always be the middle value of these two. So 0.85 minus c square root 0.85, 0.15, 1m. M is 29 now. And so the upper limit is 0.85 plus z, 0.85, 0.15 on 29. In this case, we only have one unknown, and that's z. So you can again choose the lower limit or the upper limit to find what your z is. And then once you find z, I think you get z is negative 1.80978 for this one. And z is positive of the same thing because it's standard normal distribution. And then to find your confidence amount, you just find the probability that z is between those two values. So z 1.80978, and you get 0.9296, which is approximately 0.93%. Oh, sorry, not 0.93%, just 93%, because it's to the nearest whole number. Yep.